Hello, Alex from Cars and Camera here. Welcome back to the workshop. Today I'm going to turn this perfectly usable electric car drivetrain into this complete pile of useless scrap. Don't worry, it's all in the name of education. I'm going to show you the basics of what's inside every electric car drivetrain. Okay, so you have to forgive me if it looks like it's been apart before. If maybe a few bolts are missing or some things come apart a bit too easily. This has actually been sat in multiple pieces in my workshop for quite a long time now. I just put it back together for this little video. What we have here is a Meaden Y61 motor with a gearbox and differential. This particular setup was fitted by Mitsubishi to the Outlander PHEV on the rear axle. It was also fitted to the Mitsubishi Maev small electric car. It actually puts out between 80 and 90 kilowatts, but I'll put the exact specifications in the description. So yeah, we have the motor here, the gearbox and differential section just here. Every electric car has a gearbox of some sort. Some have 2 speeds, so they flip between, or it's somewhere like this where it's a single speed and it just basically acts as a reduction drive. So this motor goes up to I think 12 or 13,000 RPM. This gearbox does a simple 1-speed, I think it's a 7-to-1 reduction. So the outputs differential, the drive shafts go in the ends here, and that's how simple the gearbox is. The motor, I think the gearbox itself is pretty heavy, as heavy as the motor. It's not very light to move around yourself, but it's lighter than an engine, especially considering the power output. So yeah, this is around about 80 kilowatts. I think 280 meters of torque, but just check in the description. And I think that's at 300 volts or thereabouts. So considering the size of the thing, it's a pretty amazing power output actually. Yeah, it's pretty incredible. So on the outside here, we've got the gearbox and differential. We've got a small connector here, which is to go to the vehicle's computers and inverter. We have some larger cable inputs here, which is where 3 large cables go in. I better not put my fingers in there in case there's any kind of residual charge, in case it moves or anything, but where 3 large cables go in from the inverter, which basically provides a 3-phase power supply like you get at home. The difference with what you get at home to this is the frequency that the phases change or interact alters, and so does the voltage, which basically influences the speed of the motor and the power it's outputting. So yeah, I'm going to pull off the gearbox now. Before I do that, there's 2 coolant inlet and outlet here. I'm not sure which is which, but I'm guessing the outlet's the slightly higher up one. Yeah, so you've got coolant pipes here because this entire motor is in a jacket of water. When I take the gearbox off and take the other bits off, you don't actually see it very well, but it has actually got a jacket of water around it because again, all modern electric cars need a cooling system. It's a bit of a fallacy to say they don't have a radiator or anything like that. They definitely need cooling because there's definitely energy there that's getting converted to movement, which means that there's going to be heat generated as well as a byproduct. So without further ado, I'm going to remove this gearbox and I mean, I've only left 2 bolts in it, which is handy. Remove this gearbox and show you what's underneath. Bit stubborn. Shouldn't be too stubborn. Okay, so I might edit that to make this look really easy. Definitely shouldn't be hammering a wedge between two cast components if you can help it. However, it doesn't look like it's actually damaged anything really. So yeah, no permanent damage. I'll make this look really easy, and here it comes. So that's the gearbox off. That's one of the outputs. It's the other output, and that's where it goes in. I won't be tearing this down today. It might be going forever, and it might fall apart and be very difficult to put back, especially doing it on the floor. It's not a clean room, so yeah, I don't want to risk making a massive mess. But we'll put this out the way. So what do we have here? So flat face of the motor itself, where it bolts up to the gearbox, and then a spline coming straight out here. In a moment you'll see where this spline leads to, but it's directly the power from the motor, and that's where all the energy goes through this fairly thick bit of metal here. So if we go around to the other side, we have this other cover on the back of the motor. Now, to get the motor apart, I have to remove this cover, and we'll see how it goes. But to start with, I'm just going to remove this little access panel here and show you what's there. Okay, so you can see where the plug to the outside here, going to the computers and stuff, leads to two plugs in here. So there's a small earth, but then there's basically a position sensor. So the inverter has to time the three-phase electricity based on this position sensor. So that goes into this plug. And the other thing that goes into this plug is this one here, which goes into the motor itself. I suspect it's a temperature sensor. Well, I know it is, I've already had it apart, but it all goes into the same plug here. Whilst I'm doing this, I should explain that the position sensor is basically the same as you get on a lot of cars. With I think it's a hall sensor on here. But yeah, it looks the same as very familiar to like a cam sensor or something like that, if you're familiar with those. If you're not familiar with anything to do with engines, yeah, it basically, they call it an encoder. Wherever the position of the moving part, the center, in relation to the sensor itself is, it just tells the rest of the system whereabouts it is. It's not particularly complicated. So we'll just get this position sensor out. I might have to go and grab a screwdriver to unplug it. It's a nice fit actually, but you kind of expect that. This is fairly precise electronics. With, expect the tolerances are quite tight, so it all spins quite fast. So what we have here is position sensor. Not too fancy, but it has got quite a nice metal mounting around it. Every modern electric vehicle motor will have a similar setup. Some will have other electronics and sensors on them. I know that Tesla's drive unit has the inverter built into it, unless I'm wrong. I'm not an expert on these, I just take a keen interest. Right, so unplug that. I'm going to take this cover off now, and then you hopefully get quite a good shot of the workings of the motor. So hi, I'm glad you're enjoying the video so much this far, but can you do one thing for me? Well, actually, a few things. Today I passed 100 subscribers and I'd like to keep the channel growing so I can produce more content. Could you just click the like button on this video? Can you please subscribe to the channel for much more content like this? And could you write a comment below? It could be idea for future content or a question about this video. I don't mind, whichever. It all looks good to YouTube's algorithms. But anyway, I hope you're enjoying it, and I presume that it must be okay if you've got this far, so I'll leave you to it. This might be another little embarrassing section of me wrestling off the cover, but hopefully not. It does feel quite snug again. Might fast forward this. Oh no, it's not too bad. So, give it a wiggle. And have a closer look. So it's all quite nice. So there is a face for the bearing to press up against. Stop it moving around. Very nice. So that's what it leaves. What we have here is the heart of the motor, really. So you've got your 3 different electricity phases coming in, and each of those goes around windings. If you don't remember from physics, lessons in school, if you pass electric current through a coil of wire, you can generate a magnetic field. And the way this basically works is by generating a magnetic field, pulling the magnet, which is this permanent magnet core, which is what the drive comes out of. You generate a field next to it which pulls it into a different position, but then you have these 3 different phases, and of those they then split into multiple windings all the way around, which is why you need to know the exact position of the thing, and it just constantly makes this core spin like crazy. Probably not the best explanation, but you should probably watch some other videos. I don't know, but yeah, so as you can tell, you can't really see the water jacket too much. It's obviously not particularly thick. I'm guessing it doesn't have to. Be. What I'm going to do next, I don't think there's that much more I can take out of it, but I'll get this magnetic core out. I might need something to press up to press it out, but we'll see, because it's heavy and very strong. Don't want to lose my fingers. Be a good fail video if so. So, if yeah. See, what I'm going to do now is what you shouldn't do with these precious, well, heavy metal magnetic cores, and that's I'm basically going to push it out through the top here, and it's going to fall down. It'll probably stick to one of these axle stands, but the impact might damage the magnet. Again, you're not really supposed to drop magnets. I think it just ruins them. So we'll try and get this out. Very stubborn though. What's that? Probably get to a point and then it will just fly out, and I'll just lean back and hopefully it doesn't hurt me. That's it, and that wasn't too dramatic, so it's out. strongest magnet you'll ever find in sort of daily use. These are extremely strong. Do not put any bank cards near them. They're that strong. Sticks to everything and it will just wipe any information. I tend not to put it next to the electronics. Apparently you're not supposed to just have it near you for extended periods of time because there's all sorts of other risks, so don't store them underneath your bed. But yeah, so that's it's very heavy, but it's basically just a big magnet with a bearing on the end and a spline, and I can probably, I can't show it spinning too well. Ooh, until it's heavy. Yeah. So we have there is the magnet in our motor. I understand that most electric motors in cars now are permanent magnet motors, which is what this is. Being permanent magnet, it means you don't have to have any brushes, because sometimes they have, the core is also magnetized by an electric charge. I might be completely talking out my arse here. It might be completely wrong, but yeah, that's what I understand. At this end, got the encoder end for the sensor. There's some nice bearings, but yeah, this is really heavy. But we'll put this to one side and I'll show you what's left. So what we have left is what we could see before. I'm going to take, let's do this. Here we go. So what you can see there, bit of a closer look, you can see this cage type structure here where the windings go up and down in big loops. There's other videos on YouTube for that and Google and things, but you can kind of see how it is in context in here. This isn't actually, this sort of structure that the cable's go in and out of isn't actually one piece of metal. It's made up of multiple what they call laminations, so it's sheets of metal with an insulative coating on them, which helps prevent some sort of energy leakage, really. I better look it up. Or it can provoke further research by the viewer if they are interested. But yeah, regarding, I mean, that's basically it. I'm not going to tear it down anymore because it's going to be very difficult because this is pressed into this casting. So that's basically how simple a lot of electric motors are. Certainly most in modern cars. They slightly make it more complex with the gear arrangement, and there might be some slight differences in the wiring, but essentially that's it. So just to recap, we've got our outer housing, I think they call it the squirrel cage, and the windings in here. Well, that's too heavy to carry. We have our magnetic core, which the output goes straight to the gearbox. We have our rear cover, which holds our position sensor. And we have our gearbox. So I hope that has been kind of entertaining, at least informative. I might have got a few things wrong. I don't think I did, but please comment if I have. I won't take it too personally. Please subscribe, like the video if you liked it. If you didn't like it, just tell me what you didn't like about it, and I'll do it better for next time. Yeah, and drop me a comment with any questions or suggestions of future videos. This was just sat around in the workshop, and I thought maybe the audience would quite like to see it. I've certainly not seen any videos too similar on YouTube recently, but I haven't looked that hard, so don't quote me on that. But yeah, join me next time for more automotive adventures, playing with cars, making a general fool out of myself, but having fun in the process. Cheers, bye-bye.